The edge of the cystine molecule, and when you use the fragments, you get pieces that are meant to be chained together. But here in the full version of the molecule, you'll see there's an oxygen here attached to the sulfur, the double bonded, I'm sorry, carbon, rather, attached to the carbon. And up here on the nitrogen, the other half of that oxygen is located here. There's the hydroxide, its hydrogen attached to the nitrogen. So we have a positive charge here on this NH3, and we have a negative charge here on this carboxyl group, and that balances the cystine off. So when I back up, there's my sulfur and my attachment point to the central, in this case I'm using the zinc. My four cysteines are not only attached, but they're completed, no loose ends. So the first thing I'd like you to check is make sure you don't have any loose ends on the sulfur or on the nitrogen. Make sure everything's bonded up. Once you've got things bonded, I've been playing around a little bit with orientation, and I've been trying to make this molecule. So let's see. Up here, I've selected the dihedral choice, and by choosing a dihedral, and I want you to imagine a dihedral is going to be 4 atoms, 1, 2, 3, 4, and in between the second and third atom of this dihedral choice, there we are, that's going to rotate. Now, I want the first 2 atoms, the first atom really, to be the rotating arm of this dihedral, and I want the second, the 4th atom here, to be the fixed arm. So on my dihedral pop-up, atom 1 will rotate, and atom 4 will be fixed. Now, as I slide the slider around, that part of the molecule can move until I find a orientation I'm happy with. So let's back up a little here and take a look at that molecule. I want to move that arm around so that it is, I don't know, as free and as open, clear from the others as possible. I want as little effect from magnetic stereo effects as possible, and I'll hit OK. I'm going to try creating another dihedral on this side. 1, 2, 3, and I've just screwed up. Let me try that one more time. Sulfur, zinc, to sulfur, to carbon. Now I'll be able to rotate that molecule. In this case, the first one I chose is the one that I should have fixed, and the 4th one should rotate. There we go. The end effect works out pretty similar. Whenever you play with bond angles and lengths and start screwing with these things, you really need to do a molecular cleanup. Gauss view has some simple molecular mechanics built into it, and with the cleanup tool, this molecule will be moved to a stable position, a stable arrangement, which makes a good beginning then to submit. Because of the large number of atoms, this one's definitely going to Hamilton.